This section begins our study on statistics. Most statistical studies are brought about by the desire to know the answer to a particular question. For instance, you might want to know which car gets the best gas mileage. The search for answers to many questions just like this is helped along by collecting data and then drawing conclusions. So we got several definitions in this section. A population is the particular group of interest in a study. Data is the information collected for a study. A census involves collecting data from every member of the population. A parameter is the numerical description of a particular population characteristic. And we'll look at examples of all these. A sample is a subset of a population. A sample statistic is the numerical description of a characteristic of a sample. So here's some differences between populations and samples. The population is a whole group, and a sample is just part of that group, because usually you can't survey an entire population. The population is the group you want to know about, but the sample is the group that you do know about, so you just make inferences about the population. Numerical descriptions of characteristics are called parameters in a population. They're called statistics in a sample. And that's easy to remember because parameters P, population, statistics S, sample. Parameters are generally unknown for a population, but statistics are always known. And the parameters are fixed in a population, while with a sample, statistics vary with the sample that's chosen. Two shortened survey reports are given. In each report, identify the following: the population, the sample, the results, and whether the results represent a sample statistic or a population parameter. A headline about the rising obesity among young people led a school board to survey local high school students. Out of 231 students surveyed, 58% reported eating a high-fat snack at least 4 times a week. So, we're going to identify each of these things. The population would be all the local high school students. The sample is just the ones surveyed, so 231 students surveyed. The results were that 58% of students or at least the students surveyed, eat a high-fat snack at least once a week. Or at least 4 times a week, excuse me. And it refers to only those surveyed. So this is a statistic. Okay? A nonprofit organization interviewed 618 adult shoppers at malls across Louisiana about their views on obesity in youths. The resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation of high-fat fast food options. So here, your population is the adults in Louisiana. The sample are those surveyed, so the 618 adult Louisiana mall shoppers. The results were that 48% of Louisiana adults favor government regulation of high-fast fat food options. This time, even though we just completed a survey, the results refer to the population. So this is a parameter. A representative sample is one that has the same relevant characteristics as the population and does not favor one group of the population over another. A random sample is one in which every member of the population has an equal chance of being selected. A stratified sample is one in which the members of the population are divided into two or more subgroups, called strata, that share similar characteristics like age, gender, or ethnicity. A random sample from each stratum is then drawn. A cluster sample is one chosen by dividing populations into groups called clusters that are each similar to the entire population. The researcher then randomly selects some of the clusters. The sample consists of the data collected from every member of each cluster selected. A systematic sample is one chosen by selecting every nth member of the population, like every fifth person in a phone book or something. And a convenient sample is one in which the sample is convenient to select. It's so named because it's convenient for the researcher. So like surveying the students in my classroom instead of the entire college campus would be convenient, as long as it's a representative sample, meaning it is similar to the entire population. To conduct a survey on collegiate social life, you knock on every fourth dorm room on a campus. And we're supposed to be identifying the sampling techniques. So since we're knocking on every fifth dorm room, then this is systematic. Student ID numbers are randomly selected from a computer printout for free tickets to the championship game. This is strictly random sampling. fourth grade reading levels across the country were analyzed by the school board by randomly selecting 25 fourth graders from each school in the county district. So it naturally divided into the 25 fourth graders from each school. So this is stratified. In order to determine what ice cream flavors would sell best, a grocery store polls shoppers that are in the frozen food section. This is convenience because it was convenient to just poll the ones in one section of a grocery store. To determine the average number of cars per household, each household in 4 of the 20 local counties were sent a survey regarding car ownership. So it's divided into 20 local counties, but every household is sent this survey. So this is a cluster sample. And that concludes this section. This one was pretty short. The next few will be quite a bit longer. We're going to look at 2 additional examples from section 1. It says, decide which study uses a population parameter. So a population parameter is determined from using something that is determined from using a population, while a sample statistic is determined from a sample. So basically what we're doing here is just determining if we're using a population or a sample in our problem. So for part A, it says, a study of 89 of the children diagnosed with cancer at Leland Memorial Hospital. 70 children were cancer-free 5 years after their first diagnosis. And it says, in a study of 89 of the children. So we're only looking at 89 of the total number of children diagnosed. So this is not all the children, so it must be a sample statistic, not a population parameter. B says, of 351 dog owners who were surveyed, 70 reported owning 2 dogs. Again, we're not looking at all of the dog owners. We're only looking at 351 of them. So this is also a sample statistic. C says, a study prompted by the increase in the use of assisted reproductive technology looked at hospital records across the country. The report stated that an estimated 3.2% of births in the United States last year resulted in twins. So in this case, we're actually looking at all the births in the United States. That is the population. So this one is our population parameter. But let's look at D just to see why that one wouldn't work. 15% of the attendees at a town council meeting in a rural area reported not using the internet on a daily basis. So this is only yes, it's everyone at this meeting, but it's only a small amount of all the people in the town. So these attendees represent a sample of the whole town. So this is a sample statistic. And example 2 says an investigator wants to know which type of vehicles access the highways in his city during the past week. He has access to traffic camera footage of each highway entrance ramp for that time period. He thinks the traffic on the ramp closest to his office is representative of the traffic on all local entrance ramps. Choose the appropriate sampling method for the scenario. So I'm just going to go through and point out what each sampling method means. Random sampling means that every member has an equal chance. Stratified is a random sample taken from subgroups. A cluster is a random sample from clusters similar to the population. Now, what's the difference in a cluster and stratified? Is that the subgroups would be like male and female. Clusters are, each cluster would have male and female in it. It would have representative from the population in each cluster. So subgroups are different from clusters. Systematic sampling selects every nth member, like every fifth number in a list of phone numbers or whatever. And convenience is what it sounds like, convenient to select. So for this one, I'd say it's one of two. It's either cluster or convenience. Convenient because he says he's saying that the ramp closest to his office is representative. But that's not necessarily the case. So I think what we need to do is look at clusters here. Choose ramps that are similar to the population. Okay? And that may not be just the one closest to his office. That might be one that he selects, but he should select more than one of these ramp cameras. And that's it for section 1.